Hello，Ted 听得到吗？听得到哈，OK。那不行啊。很好。不是啊。听得到声音吗？Hello，Ted 听得到吗？哦，好，我开始了。Hello, everyone. Welcome to RIGOL webinar. Today, I will focus on the topics of the IoT robot with the embedded circuit test solutions. And the subtopics, we will focus on how to accelerate the debugging actions by appropriate instruments. So let me introduce myself first. I'm Edward Pan from RIGOL Technologies, and based in Taiwan. I'm in charge of the technical marketing department right now. So today, I'm glad to share with you about these topics with the embedded IoT robots and how to choose an appropriate instrument to accelerate the debugging actions for your design of your product. Okay? Yeah. So now we will focus on the first agenda. So today we will have 4 sessions like to share with you. The first one, we will focus on the key technologies of the Internet of Things. And the second part, I will leverage the key roles of the peripheral system and components and how to implement the IoT robot test for an example for your reference. And finally, I will have a live demonstration of our Bluetooth and the other wireless test solutions real demonstration for you as a reference. Yeah, and we can open the question and answers time at the last the sessions. If you have any technical questions, we can have a further discussion, more detailed in advance. Okay. Yeah, so now we will go for the first slide. So I will introduce you about the IoT structure and the topologies overview. So as you know, the Internet of Things is a network of the physical objects, including the devices, vehicles, buildings, transportation, and other items embedded with the electronics, software, sensors, and network connectivities. So it will enable these objects to collect or exchange the data over the cloud platform. Yeah. So it is the simple concept of the Internet of Things. I think all of you has already known of this technology and application already. And the second part, I will separate for the IoT concept into 2 departments. The first one is from the micro view. Yeah. So what is the micro view? That is the Internet of Things allows the objects to sense and control remotely across the existing network infrastructure. So we can including the physical world and communicated-based system, such as the laptop PC and tablet equipment, or smartphone, or the post over sales the system. So we will, according to this PC platform, to help the people and human beings to connect any kind of information over the cloud system by the Internet of Things infrastructure. Okay. So let's we see the other one is the key technologies in the Internet of Things. So we can say the IoT is the technologies which can enable the last 100 meters network connectivities, like the personal area network and the local area network, whose the peripherals of the home, like the refrigerators, TV, air conditioner, cooker, or washing machine, which the devices can be connected and communicate and exchange the data over the cloud system. So the requirement of the IoT wireless technologies have some features. The first one is it has a very low cost, yeah, and lower power, lower energy, and the lower entry threshold. The most important, that is the safety. The safety is very important because it will be influence the personal's data will not be released to another one. And it all has the diversities and fit multiple standards in advance. And the IoT is the emergent communication technologies inside the structures. So the communication technologies inside the IoT infrastructure, we can refer to the below several key features. Like the first one, RFID, or the NFC, that is a near field communication. Or we can leverage the tag devices by the optical devices or the quick response code. And we also have the Bluetooth low energy technologies. And the other one, like the Zigbee, Z-Wave, LTE Advanced, or 5G or 6G telecom system. Of course, we need to leverage the technologies overall by the Wi-Fi directly. Okay. So the second session, we will leverage the key roles of the peripheral system and components within the IoT infrastructure. So the first one, we can see that is the ecosystem of the IoT system. So we can separate it for 3 levels. The upper levels is the network communication system, which will be included the communication between the telecom infrastructure and the outbound wireless connectivity of IoT system. And the second part, we can leverage this one into the embedded device system. That means it's the central unit controller part. Yeah. This layer is the most important one, implement the controlling actions and to do the data exchange or the power sequence management procedures. And the third level is the lowest level is the sensor and the components such as this kind of the devices like the optical wireless signal capturing under the device level connectivity. So the sensor and device detectors verifications is very, very important one. Yeah. So when you go to the next slide, you can see we can separate for the horizontal part, like the network connectivity, device integration, and node development. So you can see this is the key peripherals, components, and technologies inside the territories. For example, like the 5G, Wi-Fi, Bluetooth, near field communication were under the network connectivity. And like the serial bus transmission, parallel bus verification, logic state, and power sequence management were all under the device integration part. And for the inside one is node development, that is communication with the terminal connectivity, sensor, detector, verification, and signal types conversion, such as like digital nodes, that the DC to DC convergence architectures. Yeah, so you can see this is the basic signals exchange procedures across in the network, control unit, and the front-end device. Yeah, so all the procedures were implemented under the cloud data calculation platform. Yeah. And for the other ones, you can see the peripheral systems, the network connectivities is like the telecom communication. And we can see the protocol exchange was under the telecom system level. So the bandwidth will occupy the technologies for versatile standard. And it will be leveraged to the signal hopping technologies under the occupied bandwidth. And we can also doing the power quality monitoring under the system level. But the most important thing we need to focus on is the embedded device integration part. Because for the RIGOL technologies, our test and measurement technology will focus on this one level. Yeah, because we will focus on the basis of the serial bus technologies testing, like the inter-chipset communication, or the parallel bus, or the memory logic unit, or the power sequence management. So it will be included several kind of the bus type, like the I2C, SPI, RS232, I2 of sound, and even leverage to the parallel bus. Yeah. So the final one is node development. It will be leveraged to the down to the component level. Yeah, it will be included some kind of a sensor or detectors, such as the right-hand side of the screen. You can see each kind of the detector, like the antenna, or the photo detectors, or the photo diode, and even can leverage to the general type, the antenna device. Yeah. Okay. So the first second sessions, we were introducing the IoT infrastructure and the key roles of the peripheral systems and the technologies which we can leverage on. The third part, I will introduce more about the IoT robot test example for your reference. So you can see this is Arduino's Uno R3 robot test solutions. Because it will be included any kind of embedded system test solutions. So I take this example for you as a reference because it will be included some kind of application like ultrasonic sensor test, protocol test, Bluetooth communication test, infrared, power operation, load emulation, or the PWM, pulse width modulated control signal test. Even we can leverage to the final one, that is the EMI pre-compliance test solutions. Okay. So we can see the first one is the ultrasonic transceivers. Yeah, because as you can see, this is a robot. So if the robots need to move forward or backward, you need to use the ultrasonic system to test this distance. So how we can test the ultrasonic signals by the oscilloscope? So we can use the detectors and handing to the head to the front end of the oscilloscope to monitoring the ultrasonic system on the display. Yeah, so you can see the right-hand side, it is the pulse train. So as you can see, the next slide, yeah, if the distance moving forward and near the wall, that means the distance between the wall will be shortened. So you can see the pulse of the ultrasonic system will be narrowed down as the pulse width shrinks to the, like this one, from the 7.84 millisecond to the 1.48 millisecond. So we can encounter the obstacle approaching. So the robot will be stopped or take the right-hand side or the turn left or turn right actions in advance. Okay. So the second one is the protocol analysis. So as the ultrasonic detectors receive the signals, it will be react and transmit the protocol commands to the central microprocessors by the RS-232 transmission line. And the processors will wake up the stepper motors for further actions, like this one. You can receive by the protocols, and the motor will take actions to turn left or turn right, or moving forward or moving backward, any kind of actions. Yeah. So the protocol analysis, we can take the example as the RS-232 protocols. So for the next slide, you can see, yeah, it is the protocols RS-232 test point. Yeah, we can use the probe to monitoring the protocol on the display here by the oscilloscope. So for example, we can use the RIGOL MSO 5000 series oscilloscope with the RP passive probes to get RS-232 signal stream at the test point. And after proper setting of the MSO 5000 series oscilloscope, the protocol analysis result will be performed on the display. So you can see this is the test result. You can see the sequence, the signal sequence on the display, and we can use the decoding actions to decode the hexa mode or the binary mode on the central of the display here. Yeah. And we can also show the protocol table, such as the right-hand side of the screen. Yeah, so you can list down all kinds of the data performed on the data stream, like this one. Yeah. So this is the Bluetooth communication test. Yeah, so we have the Bluetooth antenna at the Arduino's main board system. Yeah, so you can see that. So it will be transmit the Bluetooth signal and across in the air, and we can head up antenna in front of the spectrum analyzer head to get the 2.4 gigahertz Bluetooth signals. So we can see the next one. We can switch to the real-time, the spectrum analyzer mode to capturing the real-time the signal, hopping signal, hopping on the display. Yeah. And later, I will have a live demonstration for this one to all of you to see the key features of our hopping signal on real-time the spectrum analyzer. So you can see this is the hopping signal, and we can also use the waterfall diagram to monitoring the time variation axis and the spectral axis, even can monitor the power trends like this one. And for the next step, you can see this one. So this is the pulse trend. That means you can monitoring the time domain signals on the spectral analyzer, both combined with the waterfall diagram and the seamless the signal stream flow on the display. Yeah. So the experiment 4, you can see this is the infrared sensor test. Yeah, the infrared sensor test, that means we can use the infrared controller signal to inspect the signals by the infrared photo detectors. So we can also convert the optical signal to the electric signal and using the probe to connect it to the oscilloscope to monitoring the signal on the display. So this is the infrared signal flow on the display here. You can see this is included the overhead signal and the stop-in signal and the stream data on the center display. So the infrared burst code data information and the overhead time durations, we can use the manual cursors to help you to capture the distance of the time signals crossing the horizontal axis and access the data on the display, like the left-hand side of the oscilloscope display here. For the first one part, the infrared, you can see this is a sensor part at the bottom side of the robot. Yeah, we can measurement this one. This is the trajectory because the array sensors responding signal was variable with the voltage threshold, depends on the width of the black strap trajectories. So it will be judged by the 3 parallel array and determine the moving directions of the robot. So it is one kind of the infrared sensor test by the array sensors. For the experiment 5, you can see the power operation test. So we can use the current probe to hook up on the oscilloscope to monitoring the current signal on the display as well. So you can monitoring the voltage signal and the current signal simultaneously. Yeah, so we can use this kind of a probe to monitoring the power transit response status with the switch on or off, and we can observe the current recovery time is the 103.5 milliseconds at this one point. Yeah. Okay, so the experiment 5, the power operation test, you can also spread the time scale to see the detailed waveform details on this one. Yeah, so you can see the variation of the current signal and the falling time as well. Yeah, so the detailed transient voltage and the current variation can be shown on the display very clearly and have a higher resolution to help the customer to solve any kind of the signal variation and interruption at the waveform curve. Yeah. Okay, this is the experiment 6, that is electronic load emulation. We can use the electronic load to monitoring the current signal on the display. So we can also use the current signal to do some comparison, and our dynamic speed can be up to 30K speed by our electronic load system. Yeah, so you can see this is a waveform variation on the oscilloscope, and we can also compare to the monitoring the current waveform on the electronic load directly. So it is the strength of our electronic load product because we can monitoring the current waveform variation on the display simultaneously and compared with the waveform display on the oscilloscope. Yeah, so it is very, very good tools and the test features to help the customer to solving your problems during the R&D procedures. And you can see the example 7 is the PWM control signal. Yeah, because our step motors was modulated by the PWM mechanism to help the motors to do some step speed on or speed down. And it is a way of the simulated analog signal using the digital mechanism. Usually we can use it to adjust the rotation speed of the motor. We will see the driving motor speed or slightly variable anytime. This is a simple of the pulse width modulation. By switching the high frequency of the digital signals and adjusting the ratio of the switch, we can simulate the analog signals as you need it. Okay. So the final one is the experiment of the EMI pre-compliance test. Why we use the EMI pre-compliance test? Because each kind of the electronic product, if we want to ship out to the other country, we need to pass any verification of the EMI test and the qualification by each kind of the country's standard. Like if you want to ship the product to the US or the North America, you need to pass the Federal Communication System, that is the FCC standard. And if you want to ship the product to the European, yeah, you need to pass the EN standard. Yeah, such as the other countries, each country has different kind of EMI standard as you like. Yeah. Okay. So that is the slide presentation. Yeah, it is a very simple slide presentation. We included to introducing you about the Internet of Things concept and the key roles of the peripheral system and the components are surrounded by the IoT. And the final one, we will take an example as the IoT robot test example to include all kinds of the test solutions, including the embedded system, protocol design, protocol test, pulse trend test, infrared, optical to electronic conversion test, and the RF signal test. Even we can do the PWM or any kind of the pulse sequence test. So now I will take an example for the Bluetooth antenna testing as an example for the live demonstration for your reference. Okay, so let me switch to the other screen. Okay. Okay, let me switch to the screen. You can see this is RIGOL's spectrum analyzers, which the model number is the RSA 5065N series spectrum analyzer. So this is the 5-in-1 instrument. How I can say that, because we can press the mode. You can see this one. Yeah. This is the 5 instruments into one system. You can see the genotype, the spectrum analyzer, and we can include it, the real-time spectrum analyzer, and the vector signal analysis functionalities, and EMI, and the vector network analyzers inside. So we have 2 ports in front of the spectrum analyzer, like this one. So the first one has this one. Left one is the tracking generator. It will be generate the synthesizer sine wave signal, and the frequency and it can be adjustable. And the right-hand side port is the receiver side. And today I will use a 2.4 gigahertz antenna hookup in front of the channel. Yeah. So you can see the screen. We will back to the normal mode for your reference. Yeah, normal mode. You can see. Yeah, this is the spectrum line showing on the display here. Yeah. So we can have different kind of the functionalities like the density. So have the density 1, you can show the advantages of the real-time spectrum mode, because all the hopping signals can be real-time shown on the display here. So it is the color grade distribution. So if the color will be deeper approaching to the red, that means the probability density will be higher at some place. And if the color will be approaching to the lower side to the blue one, that means we have the probability density is very slower. And that means the probability density is small. Yeah. Yeah. Okay. Yeah. So we can see this is the signal hopping on the display. How I can say that? So we can press the frequency, and you can see the center frequency we can set up at the 2.45 gigahertz on the display. That means the center frequency we will set at this point. Yeah. So I will use the iPhone to turn on the Bluetooth signal on to see what happens. Okay. Yeah. So if we turn off the Bluetooth signal and we will start it. You can see the Bluetooth hopping signal. Let me approach the Bluetooth signal approaching to the antenna. You can see the hopping signal on the display. Yeah, it's not clear, but I can use the other features to showing more clearly. Yeah, this is the density and the spectrogram. Yeah, okay, you can see this is the hopping signal, and this is the waterfall diagram. Yeah, let me use the trace to adjust. Okay, adjust the trace and amplitude. And you can see this one. Yeah, amplitude trace update off on, and the other one. Okay, so the signal will be displayed. Let me switch off, switch on again. You can see the Bluetooth signals again. Yeah, you can see this one. So this is the hopping signal according to the time axis, and the horizontal is the frequency axis. And we also have the Z axis to show the power density. Yeah, so you can see the different kind of the color display on the color degree on the display here. Yeah, so it is very important and a good advantage for customer to monitoring the hopping signal. And by the other one, we can see the other, you can see this one is the power sequence. Yeah, can show the 3 types of this one. So it is the power versus 1. You can see this one, trace. Yeah. Okay. Yeah, auto tune, this one. Yeah. So you can see the waterfall diagram can be shown on the left-hand side, and the power versus time can be shown on the upper side of the screen, and the spectral line can be shown on the upper side of the display. So it is very convenient for you to monitoring all kinds of the features on the display simultaneously. Okay, so how we can see the other features? Yeah, so this is a simple display by the RSA demonstration. Okay, yeah. Okay, so this is today's demonstration and webinars. So let me switch back to the slide. Okay. Okay, no problem. Okay, no problem. So any other questions from your side, you don't hesitate to raise up your hand, or you can write down your question in the right-hand side of the chat area. I can help you to answer any technical questions, okay? Yeah. So we can see the chat area. Okay, so we can see Zoom sessions of the men ahead. Okay, sorry, I will arrange the display more clearly next time. Okay, thank you for your feedback. Okay, any kind of the questions, don't hesitate to, don't afraid to raise up your hand, or any kind of the messages you can left by the right-hand side chatting area. Yeah, I can help you to answer the questions as possible. Yeah, okay. Any kind of the questions? Yeah, so we are very glad to invite all of you to join this webinar, and we are glad to help you to solve any kind of the technical issues in the future. Yeah, so welcome to contact our regional sales managers to help you to solve any kind of the test and measurement questions in the future. And I am in charge of the technical parts, so if you have any technical issues need to be discussed, welcome to contact me. Yeah, okay. So if all you guys don't have any questions, so today's seminar will be end of here. Thank you to participate this webinar. See you next time. Wishing you have a wonderful lifetime in this week, and it will be approaching to the weekend, and have a nice weekend. See you. Bye-bye.